In this question, as you can see, a variable resistance is placed and there is a long straight conductor. Right? This is a long straight conductor over which the current is flowing. This is what? This is a magnetic compass, a battery connected, an ammeter, and a key over here. The question is, if the key in the arrangement is taken out, the circuit is made open, right? That's what it means. The magnetic field lines are drawn over the horizontal plane ABCD, right? Over this plane, what will be the direction of magnetic field lines? Let me first tell you that we know that magnetic field lines in a straight current carrying conductor are concentric circles. So initially, when the current is flowing through it, the magnetic field lines will be concentric circles, as you know that. But let's understand the question here. They are not talking about the when the circuit they are talking about when the circuit is made open. That means when the circuit is open, that means the key is off. So when no current is flowing through this, no current is flowing through this, so the magnetic field lines or this magnetic compass will continue to point towards the geographical north south direction. So you should say that it will be a straight parallel lines. Ordinarily, in a straight current carrying conductor, we know that the magnetic field patterns is what? Magnetic field lines. But you should read the question properly. They are talking about when the current in the circuit stops to flow. That means when the circuit is made open. Now the in that case, the magnetic compass will point towards the north-south direction, which is straight parallel lines to each other. So in the two questions, the first question is to draw magnetic pattern of field lines due to round around a current carrying circular loop. So what you'll do here, first of all, in the exam, you're going to make a circle, right? And the circle should be made like oval so as to show it from one end. And what you can do is to connect two ends of this. Let's say if I show you, so you can connect this with a battery or a cell just to show that the current is flowing through one of its terminal. And right, let's say I take this as positive and this as negative. Now, next what you're going to do is to make concentric circles over here. So concentric circles representing over here should be like this. So some concentric circles you can make over here, and similar kind of concentric circles you can make over here. Now, let's say if the current is flowing in the upward directions here, but one more thing, let me show you first the magnetic field lines you will make at the center. At the center of the loop, you will make a straight line indicating that this is a circular loop of a very long, big circle. I mean, circle whose radius is infinity. Further, you are going to make curves over here, and the curves should be made like this. Like say, a curves above should be made like this, and below you are going to make like this. Then indicating the magnetic field lines. Now, say if since the current is will move from this is the positive to negative terminal of the battery. So therefore, the concentric curves over here you should represent the direction. This is going to be anti-clockwise, right? And then you have to reverse the direction in this case, right? This is what you are going to reverse. So this is how you are going to make the diagram. Next part is to name the rule, name and state the rule over here. So the rule is what? The rule over here, name and state the rule for to find out the direction of magnetic field inside a loop. So the rule here is what? Right hand thumb rule, right? Which we know as Maxwell's screw rule over here. This is the right hand thumb rule. And this is true for a straight current carrying conductor, for a circular loop, and also in a solenoid. So in the next question, it says, what is the question over here is when a fuse wire rated 8 ampere, it means what? So you can see I've taken a fuse wire here to show you that this is the wire, fuse wire, the inside one. This is fuse wire. So if it is of 8 ampere, it means that a current up lesser than 8 ampere. That means if the current of 8 or more than 8 ampere flows through it, this fuse wire will melt and the circuit will break. Well, this is a safety device as it will prevent any appliances which is connected with this. Right, say I took a device over here. So if the current is flowing in this direction, let's say I make the current is flowing in this direction. If the current exceeds, the circuit will break here and this wire will melt and the circuit will break and prevent any appliances from getting damaged. Well, it works on the principle that if the rating is 8 ampere, it will continue to work. It will work even if the current is flowing lesser than 8 ampere, and the circuit will break if the current exceeds. It will burn if the current exceeds 8 ampere, right? So this is the correct option. Now other options are incorrect because it will not work if the current. It will work. Any current flowing through it lesser than 8 ampere will work. It will burn out only when it is 8 ampere or above it. In this question, we have to identify the structure which depicts correctly the compound calcium chloride. So what we are going to do here, we are not just going to select, we are going to understand the formation of ionic compound here of calcium chloride. Calcium, whose configuration is what? 2882, loses 2 electrons to form Ca2 plus ions after losing 2 electrons. Now similarly, chlorine, whose configuration is 287, will gain 1 electron to form Cl minus. Now over here you need to understand that calcium with has 2 electrons in the outermost shell, right? Say if I use cross here to indicate here, as for the uh, options given here, and chlorine, which is having I use dot here with 7 electrons in the outermost shell. Now check here, 1 electron can be transferred from here to here, but then chlorine, another electron is to be transferred. So therefore, 2 atoms of chlorine will come. Let me show you. These are again another chlorine atom with 7 dots indicating 7 electrons over here. 1 electron will be transferred from here to this, and the other electron will be transferred. So what you can figure out, calcium now will have what will be represented as Ca2 plus. The negatively charged ions is placed inside a bracket, and then you can see these are dots indicating the electrons that chlorine had, and this is one taken. Now why did I so? Since I'm representing only one chlorine atom here, but as you can see there are 2 chlorine atoms, therefore I should write 2 in this subscript, while the charge in the electron must be represented in the superscript, that is as a power over here. So this should be the correct representation. And as for the options, if I compare this with, I can see that C is the correct option in this case. So here what we can see that electrolysis of water is given, and we have some MCQ based on this, but I would tell you first write down the reaction involved to justify the answers. Now I have written the electrolysis of water where electricity is passed and water is decomposed to produce hydrogen and oxygen. This is what I balanced it. Now let's say first one, you know that hydrogen is what? Hydrogen is negatively charged, a positively charged ion, so it will be produced at the cathode. So and oxygen, which is negatively charged ion, is produced at anode. Further, you can see that while balancing, we found out the amount of hydrogen gas produced is twice that of the oxygen. From here you can see. Now if I read the options here, the first one, it says that at anode oxygen gas is evolved. At anode oxygen, right? At anode you can see I have marked anode, oxygen gas colored. The next one is in the test tube covering the anode, the amount of gas collected is twice the. So covering the anode is oxygen, and right at anode oxygen gas is produced. You can see over here, and the gas collected in anode is double that of the gas in the cathode. That's not correct. As you can figure out from here, the hydrogen gas is twice of oxygen. So first is correct, but Well, I say this is correct, but this is not correct. Now, at cathode, hydrogen gas is evolved. At cathode, yes, it is hydrogen gas evolved. Now, it is a decomposition reaction. So, yes, it's a decomposition. As you can see, a single substance splitting into more than one product. So, from here, we can see the correct option should be first, third, and fourth. First, third, and fourth is what? First, third, and fourth is this. So, this is the correct answer for this question. In this question from the assertion reasoning, as you can see, a reaction is given over here, right? And well, the reaction, they are saying that this reaction is a redox reaction. So clearly you can see that oxidation and reduction is taking place here simultaneously. So we'll say that assertion is correct over here. This assertion is correct. Now, when I read the reason, it says that in this reaction, H2S is getting oxidized. Let's see the H2S. What you can see, just this portion of H2S. This is H2S over here. And this, yeah. So this H2S is oxidation to H. Yeah, this is correct. As you can see, hydrogen is lost here, and loss of hydrogen is what? Oxidation. So this part is correct. Now the later part is what? Oxygen is gaining hydrogen, and gain of oxygen is reduction. So we'll say that assertion is correct and the reason is also correct. And we can see that the reason is correct explanation because an oxidation and reduction when takes place simultaneously, we say it's a redox reaction. So we'll mark option A as the correct option in this case. In this question, we have to identify X, Y, Z in the given reaction. Let's begin with the first one. If I move towards left, you can see this is ethanol, and ethanol when heated with hot concentrated sulfuric acid. So what do you know that this is nothing but dehydration. So in dehydration of ethanol to produce what? Ethene, which is C double bond C. Ethene is this. You may write C2H4 also. And here, this is the dehydrating agent. Well, there is another product that is water is produced. That's why it's called dehydration. Now, if I move to the next, that is towards the right hand side from here, what you can see that, so we identified X here. Let me just tell you that what we have as of now got is this product, and this is X here as for the question. So X is this. Now, once we got X, let's move to the next. Now, if I move with this reaction towards the right-hand side, that's from here, we get Y. And this is what ethanol reacts with alkaline KMnO4, which is acting as an oxidizing agent to get what? To give, this is ethanoic acid. I should show you the reaction. Well, this is the reaction involved here. So Y is this, right? In the presence of alkaline KMnO4, or can be in the form of acidified dichromate, the result is ethanoic acid. So we got Y as ethanoic acid. This is Y here. Now Z is what? We can see that this is esterification. So esterification is what? When ethanol react with ethanoic acid. If I write down the reaction, ethanol is what? C2H5OH. When it reacts with ethanoic acid, this is CH3COOH. In the presence of an acid, results to give you Y. And what is Y? Y is ethyl ethanoate. That is CH3COO. This is OO. C2H5. So this is the product Z here, which is ethyl ethanoate, and we know them as an better as ester. Why is it? And that's reaction is called esterification. Let's move to the table is going over here. You can see that this is the compound methanol, ethanol, and propanol. As you can see, they belongs to the same functional group, and this is actually a homologous series of aldehyde, right? With the first member methanol, then ethanol, then propanol, and then butanol. Now, what is the question over here? Yeah, that information is already given here, and the table shows the formula, its melting point, sorry, boiling point in degree Celsius, and its solubility. So list two characteristics of this homologous series. Well, you should see that there is a gradation in the physical properties. You know that in a functional group, as you go down in a functional group, what you can observe, it's melting point and boiling point increases. And this is because you can see that as you go down, the number of bonds between the number of bonds increases, and therefore more energy is needed to break this bond. And that's why we say that there's a gradation in the physical. Gradation is what? The gradual increase in the melting point and boiling point over here. And the other property you can see over here, that the solubility is decreasing, very soluble to soluble and then to slightly soluble. You can add one more over here, that here the each member varies from its succeeding and preceding member by CH2 group. That means the next member is obtained by adding CH2 to the preceding. Now here is one more. Compare the formula of the 4 aldehyde listed in the table. Okay, that's what the answer for the what I have already answered. As you can see that each member varies from its succeeding and preceding member by CH2 group. CH2. You add CH2 on this, you'll get this. You add CH2 on this, you'll get this. That's about. Now we have to do one more part here, is to draw the electron structure of ethanol. So this is ethanol. So first I'll do the bond structure here. Ethanol is what? C double bond O, single bond H, and this has 3 hydrogen. Now what I'm going to do is to draw the same thing, but this time I will replace this. I'll just write everything over here, just copying it. And now I'm going to place cross and dot over here, representing, say this is cross dot, cross dot, cross dot. Between carbon height, whenever there is a single bond, it's cross dot, and I'll say use cross dot again here. Well, oxygen, let me first make the octet rule for, not octet rule, for hydrogen. There are 2 electrons. They need to satisfy and attain the noble gas. For carbon, between carbon atom, you can see there is single bond, so I represent it with cross cross. Now check here, this is satisfied with the octet rule, 8 electrons. This carbon has got 8 electrons. Let's figure out oxygen. Oxygen has already shared its 1 electron, so it is left with 6 more electrons over here. Now this oxygen will also now get 8 electron. So this is how you will represent the electron dot structure of ethanol. Question here is, first is to draw the structure of cyclohexane. Well, cyclohexane, as you should know, that it forms a ring chain. So first I'll do what you should do in the exam is to place 6 carbon atom, 6 carbon atom in the form of a ring. So this is 2, this is going to be 3, this is say 4, this is 5, and this is 6. First you join them with single covalent bond, right? And as you can see that this carbon atom has 2 unsatisfied valencies. So let's place 2 bonds in each case, and we'll be joining hydrogen to this. So if I write hydrogen, is going to be what? This is hydrogen, 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 hydrogen. Now there's something which is very important I want to say after ending this structure. Now, many of you actually see this as a hexane and end up writing the formula as C2H. No, hexane is C6H14. Well, this is not true because it is cyclohexane and not hexane. It will have 2 hydrogen less than this. So its molecular formula should be what? For cyclohexane I'm talking about, it should be C6H12. And you can do back counting to figure out this. Now below you can see there is another question, is to name the compound, and this is the structure. Well, this can also confuse a student while considering this to be a ketone. Remember, ketone never joins at the end, right? If ketone has to be there, it has to be there in the between 2 carbon atoms. So for a ketone, there minimum 3 carbon atom is needed. So what is this? This is aldehyde. As you can see, C double bond O, single bond H here. Ideally, we don't make a structure in the exam, but the question paper can have this kind of structure. So this is with aldehyde with 2 carbon atom has to be called ethanol, right? We are doing one case study question over here. As you can see, this is the case, and this is what the question followed by it. So let's read the question over here. It says when a silvery gray powder Al is mixed with a powder solid B, no reaction occurs. But if the mixture is ignited and lighted using magnesium ribbon, a reaction takes place with the evolution of large amount of heat forming a compound C, which settle down at the liquid metal, and the product D is formed that floats on liquid. So very big. In a solid that form reacts with moisture to form rust. Okay, right. So one thing that we can identify from here is what that about the compound C. The C, as you can see, the compound C reacts with moisture to form rust. So C is clearly what? C is iron over here. So let's figure out first thing. Now later it says that this reacts with aluminum, and a compound of this, right? A compound of this reacts with aluminum, right? So we know about the thermite reaction. So it has to be thermite reaction here. Aluminum reacts with ferric oxide. So Al, aluminum reacts with what? Ferric oxide, that is Fe2O3, right? Yeah, that's what displacement reaction takes place. And here, what is produced? Iron is produced, and iron so produced is in the liquid form. And what else is produced is Al2O3. Right, so now we identify B as well. So this is going to be B. We identified C, already we identified C over here. We identified B, and D is what? As D I can see is aluminum oxide, and C is identified. What is left? Okay, A is left. So clearly A is aluminum here. So we got ABC. Now we can answer all the questions over here. Okay, the first part was only to identify and write down the balance reactions. Well, the reaction I've written the first, and the balancing I'm leaving. Now next is to reaction of this with, it reacts with air. So aluminum when heated in air, that means it reacts with oxygen to give you what? Aluminum oxide, Al2O3. There's one more part over here is what? The last part I can see is, does A reacts with aqueous sodium hydroxide and hydrochloric acid? Yes. You know that this is an amphoteric oxide, right? Aluminum oxide is what? An amphoteric oxide. So it will react both with acid as well as base to give salt and water. So we should write down the reaction. Aluminum oxide when reacts with acid, this part is easier. So you will get aluminum chloride, AlCl3 plus H2O. I'm leaving the balancing part and mention and not writing the aqueous and its state. And similarly, this aluminum oxide being amphoteric will react with base as well to give salt and hydrogen gas. But you have to remember the base is sodium aluminate, that is NaAlO2. This is sodium aluminate plus water. Yeah, as I said, it is an amphoteric oxide, so this will react both with acid as well as with base to give salt and water. This is the salt and water.